Okay, this video is part 1 of our lesson on polynomials. Okay, and this video will focus on factoring polynomials completely and solving equations by factoring. Alright, problem number 1, we are factoring completely. What is the first step of factoring? GCF should have been what you just said just now. Is there a common factor that we need to factor out? Well, no. 3 is prime. There's no x's, so no GCF. Since it's a trinomial, then our only hope is that this will factor as a binomial times a binomial. We start by looking at the 7x squared, and that can only factor as 7x times x. Okay. Next we look at the 3. Again, pretty easy. 3 can only factor as 3 times 1, or 1 times 3. Okay, I'm going to purposefully choose wrong here at first to emphasize that this is a trial and error type of a situation. So we don't know if it'll be 3, 1 or 1, 3. But here's how you find out. Say you try the 3, 1 option. The key is inner plus outer must equal the middle. Okay, so that means we should be looking at the middle right now. Now inner, when I say inner, I'm talking about these. When I say outer, I'm talking about these. Okay, so right now inner I have 3x, outer I have 7x. I'm multiplying, by the way. 3 times x, 7x times 1. These two have to add up to the middle, 20x. I can pick the signs however I want. There's no way to get 20 out of 3 and 7, so that's how I know that this setup is not going to work, this order. So instead I will try putting the 1 here and the 3 here. Okay, if I do that, now inner I have 1x and outer I have 21x. Alright, now can I get 20x out of 1 and 21 if I pick the signs right? Sure I can. If I have a positive 21 and a negative 1x, that'll give me positive 20. Okay, so my negative 1 is right here, and my positive 21 will happen if I make the 3 positive. Before we call this the answer, I need to check one last thing. I need to look at this sign. Am I getting a negative 3? Well, yes, a negative times a positive is a negative, so that's good. So that means we factored it correctly. Okay, now one more thing. On some types of problems, we factor and stop. On other types of problems, we factor and we keep going, setting the factors equal to 0 and continuing on to get x equals something. Am I finished? Is this the answer? Or do I need to set these equal to 0? I am finished. I'm done right now. Because this is a factoring problem. When we get down to problems like number 3 that say solve, and it's an equation, see the equal sign, these are the problems where I start off by factoring, but I keep going, and I set the factors equal to 0. But this is just a factoring problem, no equation, no equal sign, so this is the answer right now. Alright, that's it. Alright, on number 2, we are still factoring. What is the first step of factoring? That's right, GCF. Okay, so we have 16 and we have 128. They're definitely both even, so they're both divisible by 2. But, you know, looking at 16, here are some factors of 16. 2 goes into 16, 4 goes into 16, 8 goes into 16, and of course 16 goes into 16. So we want the greatest common factor. So looking at 128, I'm not familiar enough to know. You know, it looks like 4 will probably go in because of the 8. But I don't know, does 8 go in? Does 16 go in? So let's use a calculator and see. Let's start with a 16. Is 128 divisible by 16? Okay, so 128 divided by 16. Oh, okay, it is divisible by 16. Okay, so that means 16 is going to be the GCF. So let's go ahead and pull out that 16 and see what we've got. So if I pull out that 16, okay, and remember, when we pull out a GCF, we are dividing. Hey, come say hi, Maya.
What's up, peoples?
Alright, that's my daughter Maya. Alright, carry on.
Okay.
So we're dividing by 16. So that's why I'm going to get just x to the third power minus, and we saw that 128 divided by 16 is 8. Okay, so we have this. Now, this could be the answer, I guess. It depends on whether this pink part is factorable or not. Do you know any way of factoring this? There's only 2 terms, and this is cubed. So, you know, it's not the difference of 2 squares, which is one of the 2-term polynomials that we've learned to factor. But there's one more special case that we've learned to factor that had 2 terms in it. And that was the sum or difference of 2 cubes. 8 is a perfect cube because 8 is 2 to the third power. So this is the difference of 2 cubes. So focus on the pink part, because we learned a pattern of factoring the difference of 2 cubes. And the pattern was this. If we have the difference of 2 cubes, that will always factor as a binomial and a trinomial. The binomial comes from just taking the cube root of the 2 terms of the original problem. Alright, so the cube root of x to the third power is x. And then just bring down that minus sign. The cube root of 8 is 2, as you can see here. Okay, so the binomial is simply x minus 2. Okay, now the trinomial. Alright, when we talk about a trinomial, obviously we're talking about 3 terms. Okay, a beginning, middle, and end. Alright, I like to do the beginning and end first. The first term of the trinomial comes from the first term of the binomial. And similarly, the last term of the trinomial comes from the last term of the binomial. And what you do is you square them. Okay, so if I take this x and square it, then I'm going to get x squared. Actually, let me not do that in this color. Okay, I'm going to get x squared. If I take 2 or even negative 2 and I square it, I'm going to get positive 4. Okay, so that's how you get the first term and the last term. Now, for the middle term, you multiply. Okay, I'm still dealing with the x and the 2. Alright, I'm still dealing with these 2 terms, but I multiply. Okay, so x times 2 is 2x. And it's always going to be the opposite sign we learned. So since this is negative, this will be positive. If this had been plus 2, then this would have been a minus 2x. Alright, and so there we have successfully factored the difference of 2 cubes. Okay, so we just need to remember the GCF that we pulled out. Alright, because that's still waiting patiently out there. Okay, so now this trinomial can never be factored more. So we're done. This will be the final answer. For number 2. Now, number 3 is a different type of problem. It still involves factoring, but we are solving by factoring. So we're going to have to go a step further. But still, the first step of factoring is to look for a common factor. GCF, greatest common factor. And I see that these are all divisible by 4. So that's going to be part of it. So let's pull out that 4. But also, all of the terms have x's. Alright, the lowest amount is 1. So they all have at least one x. So that will be part of my GCF. Okay, now I will look at what is left on the inside once I do that. And when I do that, I am dividing by this GCF. So I'm taking my 4x and I'm dividing by it. Okay, so those 4's are gone. X to the third power divided by x is x squared. Alright, I will just have my minus x. Alright, these 4's canceled out. This x cancels one of these x's out. And 8 divided by 4 is 2. And this x cancels out, so that'll just be minus 2. This trinomial is surely factorable further. So let's keep going, and there's no GCF anymore, obviously, so we'll go ahead and factor this as a binomial times a binomial. X squared can only be x times x. 2 can only be 2 times 1, and it doesn't even matter where we put it because it's the same x. But the signs. Remember, inner plus outer equals middle. This is the inner, and this is the outer. So inner, I have 2x. Outer, I have 1x. If I'm going to get a middle of negative x, I need a negative 2 and a positive 1. Alright, so there's my negative 2, there's my positive 1. Let's make sure I'm getting this negative 2. Negative times a positive is a negative, so I am. Okay, don't forget about the 4x, it is still there. So now we have factored completely. However, this is still an equation. We are not finished. We are solving. We're not just factoring this time. So we need to keep going. So we need to take each one of these 3 factors, 1, 2, 3 factors, and we need to set them each equal to 0. Okay, so we're going to go, alright, 4x equals 0. And we're going to go x minus 2 equals 0, and x plus 1 equals 0. Okay, dividing both sides by 4. Here I'm getting x equals 0. That's one of my solutions. Okay, here adding 2 to both sides gives me x equals 2. So that's another solution. And here subtracting 1 from both sides gives me x equals negative 1. Okay, so this problem had 3 solutions. In general, the degree is going to tell you how many solutions there will be to the equation. So there's a degree of 3, so we were expecting up to 3 solutions. The only way we will have fewer than 3 solutions is if 1 or more of the solutions are repeated. Okay, for example, if this had been, just imagine for a minute this had been x minus 2 and another x minus 2. Well, then this would have been x equals 2 and we would have gotten another x equals 2. So it would have looked like we only had 2 solutions, 0 and 2. But really one of them is repeated. So if you count the repeated one, it would still be 3. Anyway, that's not what happened. Okay, so that's it for number 3. Alright, well this is a curious little problem. We're supposed to solve this by factoring. If you're going to solve a problem by factoring, you need to have 0 on one side. So we can use that 0 product property. So yeah, let's subtract the 80 from both sides. So we can get 0 on one side. So that gives us 5x squared minus 80 is equal to 0. Now, the first step of factoring is the GCF, factor it out. Okay, this ends in 0, so we know it's divisible by 5. So let's definitely pull out that common factor of 5. Okay, so
Sorry, kids.
we're dividing by 5, and that's going to tell us what goes on the inside. So this will be x squared minus yeah, 16. So it is. So that's going to be 16. Now, this will factor further, so let's go ahead and rock that. X squared minus 16 is the difference of two squares. So I can go x plus 4 times x minus 4. Alright, and I still got that 5 sitting there. And this all equals 0. So I've got these three factors, and so normally I would set them all equal to 0. But you know, 5 cannot equal 0. So there's really nothing you can do with that. So disregard it. Okay, but the rest of these I will set equal to 0. So x plus 4 equals 0 and x minus 4 equals 0. So subtracting 4 from both sides, we get x equals negative 4. So that's a solution. And adding 4 to both sides, we get x equals 4. So this problem had two solutions. Again, look at the degree. The degree is 2. If the degree is 2, we would expect to have two solutions unless one of them is repeated. Okay, and let's go ahead and stop this video here, and we will pick up the next video with graphing quadratic equations. Okay, parabolas. Good times. See you on the next video. Bless you.